All right, 2.4 video, we're just going to recap what we've learned because we learned a lot in 2.2. We talked about biconditional statements, we talked about logically equivalent, and we talked about the law of syllogism. So this video, I just want to recap and hopefully we can merge them all together. So the first thing we talked about, I want to talk about is our biconditional statements. So biconditional statements, remember, have that word if and only if in it. And also, it means that the converse and the inverse are both true. So the converse is true and the conditional statement are both true. Conditional are true. So if you read it forwards or backwards, it's going to be a true statement. So, I also said that biconditional statements are definitions, like things that you learn in science. So let's look at these pictures here. I'm going to tell you that this is a square and that these are not squares. This is problem number 1. Not squares. So based on this picture, can we come up with a definition of a square? Well, a square has, it looks like all the sides are the same and that they have 4 angles. So that's something about a square. These are not squares. This one has all 4 right angles, but it doesn't have 4 congruent sides. And this one has 4 congruent sides, but not a right angle. So let's see. We know that the inverse and converse needs to be true. We know that there needs to be an if and only if in there. So I can start off by saying a figure is a square, maybe. That's what I'm going to say. A figure is a square if and only if, did I put too many F's? Yes. If and only if it has 4 right angles and 4 congruent sides. So that would be my definition of a square. And I'm actually going to change figure to be polygon. That'll be more accurate. And we'll talk about that more in chapter 6. So this is an example of a good biconditional statement, a good definition. What I want you to do for number 2 is I want you to change this. I'm telling you that this is a bad definition. An angle is a geometric object formed by 2 rays. This is something we learned in chapter 1. I want you to, for number 2, tell me why is this a bad definition and change it into a better one. Change it into a better definition and a better biconditional statement. Okay, the other thing we talked about was logically equivalent. Logically equivalent means exactly the same truth value, right? And my hint for you guys was it really means contrapositive. So if you see something on a test, on the state test or anything, because I guarantee you'll see this, if you see something logically equivalent or same truth value or which one is a valid, make a valid statement, they're really wanting you to do the contrapositive. And contrapositive, remember, is when you flip it. You flip the statement and you negate it. So you're going to do 2 things. You're going to flip it and you're going to insert those no's. Flip and no's. Okay, sweet. And then the last thing I want to do is merge this all together. So here's one more problem. If a triangle is a right triangle, then its acute angles measures are complementary. If one angle of a triangle is a right angle, then this triangle is a right triangle. Since we have 2 statements, we're going to have to use the law of syllogism. And remember, law of syllogism, remember what I want you guys to do is just rewrite it in shorthand. So let's see, if we have a right triangle, I'm just rereading this first sentence, then its acute angles are complementary. So I'm going to put acute are comp. Great. So what that means is if this is 90 degrees, then these 2 other angles, these 2 acute ones that are left over in the triangle have to add up to be 90 degrees. That's what that statement is saying. So the second sentence, if one angle of a triangle is a right angle, so let's see, if we have one right angle, then the triangle is a right triangle. Okay, so let's see. The law of syllogism says we're going to get rid of those things that repeat, and we're going to put these 2 things together. So since this comes first, our conclusion will be that if we have one right angle, then in a triangle, right? One right angle in a triangle, then the acute angles are complementary. And this was an easier example because you guys know about triangles and what complementary means and what acute angle means. On the test, I might give you something that you know absolutely nothing about, but this process is what you're going to do. You're going to get rid of the things that repeat and then push the other 2 things together. This is what I want us to talk about, though. What statement? This is one statement. What happens if you read in the multiple choice test and that's not an answer? Then what you have to fall back on is logically equivalent. Okay, what's logically equivalent to that? And you know that that means contrapositive. So what that means is you're going to have to flip it and put no's. So another answer that could be on the multiple choice test is if you have, if the acute angles are not complementary in a triangle, then there is no right angle in the triangle. So both of these could be answers on the test. So that's something maybe to look out for. And then the last thing I want you guys to do is write a biconditional statement based on your conclusion about right triangles. So you're going to write another biconditional statement. And then we're all done, and hopefully you have a better understanding of those three terms.